Hello. Welcome back to the final episode of My Tutor AI Squads. This is day 10 of our squads. Yeah, I can't believe that it's finally over. I think we've covered quite a lot for 10 weeks worth of content, and I hope you all really enjoyed what we've learnt so far. But yeah, like every single session up till now, we will be starting at 5 past, so it is 5 o'clock now, but at 5:05 we will begin our session today on artificial neural networks. But for those who are just joining or who've just give me a quick message, let me know you're there, and tell me how your day's been, what you've been up to. It's been a pretty regular Tuesday for me. Not much has been going on in my life, but I'd love to know what's going on in yours. And as the mod Inga has put in the chat, there is a link that you guys can click, and that allows you to share all the sessions with any of your friends and family, just anyone you think might be interested in computer science or artificial intelligence. You can share it along. Hello there, Comet. Nice to see you again. How are you doing today? I think I say this every single time, but I do like the fact that I can start to recognize names as they pop up throughout the weeks. You're doing alright, you? Yeah, I'm not too bad. It's been a pretty good Tuesday so far. You been up to anything, Comet? Yeah, like I said at the start, we will be starting at 5 past. Is there anything else I need to tell you? I don't think so. There's no installation-y stuff that you have to do this time around. Most sessions we've had to download some kind of data set. You don't have to do that this week. Everything is all on the browser, which is quite nice. And Comet has said, been ill most of the week, so not much, haha. Aww, I'm sorry to hear that you're ill. I hope you get better soon. I was ill, I think, last week? Maybe the week before? I'm not sure. Weeks kind of are a bit funky when you're in uni, but I think I was ill last week and it was pretty bad. So I think there's just bugs that keep going around every uni and school. So I can feel your pain. Those of you who are waiting, if you're interested in setting up your session, we are just going to use Google Collab today, like we have for about 5 weeks now. So should be pretty familiar with that. And Brian has said, Brian, nice to see you again, Brian. It's good to see a familiar name. Also, since it is the final session, if you guys have got any questions on just anything that we've covered through over the past 10 weeks, now would be the best time to ask it. I'll give you guys a little bit of time at the end of the session as well, if you guys have any questions on, artificial intelligence, computer science, any of those questions or queries that you've had, anything that you maybe didn't understand at a previous session or anything like that, now would be, or this session would be the perfect time to ask those questions. So if you get any in your head, just write them down, keep those in mind, and then I'll see what we can do. Oh wow, it's the final one. What was your favourite AI thing? From Brian. Ooh, that is a good question. I quite liked some of the stuff that we did in the earlier sessions. I really liked the face recognition stuff. I think that's really cool. and a lot of the image classification stuff. I think that was my favourite one. What was your favourite? Oh, it is 5 past. So I will get started while you Okay, that is 5 past. So, first of all, can everyone see the presentation on the screen for the final time? If you can, please write yes, so I know that you can see it. Same was a fan of that one. That's good to hear. That's really good to hear. Okay. I'm assuming, since no one is complaining in the chat, that we can all see the presentation on the screen. So I will continue, and then if you can't see the presentation for whatever reason, please just message in the chat, Fliss, we can't see the screen. But yeah, this is day 10 of My Tutor AI Squads. Comet Remix, yes, we can all see. Fantastic. And today we are covering probably the most advanced topic that we've covered thus far, and that is deep learning. Fair warning, we will be covering quite broad strokes in this session. A lot of the stuff that we're covering, people have written papers on just tiny little bits of it. So I'm not expecting you guys to understand everything that's going on. I'd just rather you enjoy the process of making a deep learning algorithm. That being said, what is a deep learning algorithm? So you've seen this diagram quite a few times throughout these sessions, breaking down what different AI bits. And well, deep learning is that middle one there, and that's essentially working with artificial neural networks. So yeah, deep learning is a subset of machine learning that mimics the way that the brain learns. And there's lots of different applications for deep learning. I am a Google brain, I can handle this. Yes, yes, says Brian. Fantastic. I'm glad that you're able to handle this. What was I saying? Yeah, applications. There are numerous applications for deep learning. A few of them are self-driving vehicles, for example, playing games, image recognition, voice recognition, natural language processing, many, many, many more. So they're really, really useful, and they're quite a hot topic right now. So any of you interested in all these different applications, you could probably find a use for them. And the one we're covering today is an artificial neural network. So let's start with the basics. So an artificial neural network is a type of computer program that is designed to learn how to do a specific task. This could be recognizing handwritten digits. That's the one we're going to do today. And it does this by using a lot of data and a special type of maths, which you've all done before, if you're at least at GCSE level, and that is called calculus. So how does it work? Well, imagine you're trying to teach a computer how to recognize the number 7 when someone writes it by hand. Oh, I got a question there. What applications use deep learning specifically? I can't think of any specific brand names, but there's a lot of different applications for deep learning just across the board. I gave you quite a few there already, but you could probably Google just deep learning applications and 1,000 different companies would come up. So don't worry about that, there's plenty. What was I saying? Yeah. So imagine you're trying to teach a computer to recognize the number 7 when someone writes it by hand. So the computer would start by looking at a bunch of examples of the number 7 that has been written, like on the screen. And these examples would be in the form of digital images, where each pixel represents a tiny piece of the picture. The computer program would then use a special algorithm to analyze all these images and figure out what kind of patterns are common to the number 7s. For example, it might recognize that there's a vertical line down the middle and a horizontal line at the top. This is my very botched version of what a 7 looks like. And then once the program has figured out what all these common patterns are, it then can create a mathematical model to recognize them. And this model is made up of a bunch of interconnected nodes, which are sort of like how the neurons work in the human brain. So each node takes some information processes it in a certain way, and then sends that result to the other nodes in the network. So for our example of the 7 algorithm, one node might look for the vertical lines, while another node might look for the horizontal lines. And then these nodes would work together to recognize the different parts of the number 7. So how do we then train this neural network to recognize these handwritten digits? Well, we'd use a data set called the MNIST, the MINST dataset, and this dataset contains thousands of images of handwritten digits along with the correct labels for each digit. So then the program would use this dataset to train the neural network, and this means that it would adjust all the connections between the nodes to make the network better at recognizing the digits. And then once the network has been trained, it then can be used to recognize new handwritten digits that it has seen before. So if you were to write a number 7 on a piece of paper, you could scan that image in, and the neural network could figure out what number you wrote. And that's basically how artificial neural networks work. They're really, really good at recognizing patterns in data, and they can be used for all different types of tasks. So, before I go on to actually showing you how to build one yourself, does anyone have any questions on how these artificial neural networks work? I realize I did say that entire explanation in about 5 minutes, which is not a lot of time. So if you do have any questions, feel free to just post them in the chat. Brian says, I understand, it uses patterns to work. Yeah, pretty much, yeah. Okay. Again, feel free to post any questions you have just in the chat. But for now, for the next 20 minutes or so, we will actually build our own artificial neural network. We're going to be using Google Colab today. We've used this throughout the sessions, and I've got mine set up on the screen here. So I'm going to give you guys a few minutes just to set up your own Google Colab, and then when you're ready, let me know, and we'll get started. All good, fam. All right, no worries. I'll give everyone a few seconds. Comet Remix says they have it open. I think having 2 people say that they've got it ready is probably good enough to start. So, we are going to be using 2 different libraries today. The first one we're going to use is TensorFlow. So, you're going to write import TensorFlow as TF, and we're going to be using pandas for data manipulation. So, import pandas as PD. I have no idea what Brian's written into the chat. Honestly, sometimes I feel like Brian could be speaking French, and I would be none the wiser. But hi there, Michael. Nice to see you. But yeah, once you've written those 2 libraries, let me know, and I will carry on. I've written it, some people have joined, so you should probably wait a bit. Yeah, that's probably fine. I will warn you guys, this one is, long. Yeah, so we might run over slightly. So I'll try and keep the pace a little bit quicker than I normally do. And we might run over just slightly. Hopefully you guys are interested enough that you can stick with it. But yeah. The next step, once you've got these libraries, I'm going to press code so I can get another little bubble. And in this little coding bubble, I'm going to add in the data set. Now, throughout these weeks, we've used a bunch of different data sets in the form of CSV files that we've downloaded. But this data set is so famous that you don't need to download it. It's already included in the library. So you can write MNIST, that's the name of the data set, and then to download it, you write tf.keras.datasets.mnsit, and that downloads it into that variable there. And as you can see, it comes up as the handwritten digits data sets. If you're interested in what it actually looks like, the data set, you can just Google it, it will show up. Haha, I do try to open the website, but Wi-Fi was like, never, let me see what it is. Honestly, Brian, it looks like you've been, like, possessed by some kind of AI. I wonder if you're just getting an AI to write these for you, because it's, I've never seen people type like this before. It's very strange. But you do you, Brian. But yeah, so once you've added in the data sets, then you can divide the data set. You don't have to write these comments, by the way, I'm just doing it for you guys, into training and testing. You've seen this 1,000 times. Splitting stuff into training and testing data sets. We've done this so many times throughout the past 2 weeks. So, but if you need guys need a refresher, I will explain it to you. But basically, we're going to split train data and train label. Make sure to put it in these brackets. Comma, test data. I'm glad to see that everyone's got the data set on their computer as well. Test data, comma, test label. And then to load it in, you just write equals MNSIT dot load data. Open brackets, close brackets. And if I run that, that will then put all the data into these variables, which is nice. And then what we have to do is we have to divide the training data and the test data by 255, because that helps with the pixels of the image. So train data and test data equals train data divided by 255, comma, test data. I could have done these separately. I probably should have done these separately. It might make more sense to you guys. But it's basically just divided both of them by 255. And that's the first step done. I'll give you guys a minute to write that down. And then we'll go to the next step, which is actually building the model. If I can even spell building the model. Building the model. Alrighty. This section takes quite a bit of explanation. So what I'm going to do is I'm going to do it first and explain it second. Hopefully that will give you guys enough time to write everything while I'm explaining what you're doing to you guys. But we are going to build our artificial model. Brian says, I'm struggling a bit, but I got the... Is it okay if you take a minute while I write the code? Yeah, sure, I can wait a minute. I realize because I've done this before, it's very easy for me to go through this very quickly. But yes, I can wait for you. I'll give it another minute and then I'll get started. I've also got 2 cups of coffee with me. It's a 2-cup of coffee kind of day. So if you notice the changing mugs throughout this episode, that's why. Okay, Brian says it's all good now. So, let's build our model. So our artificial neural network, as you saw in the diagram, is made up of a bunch of nodes, and these nodes are sorted into layers. So we're going to build those layers right now. So I'll show you how to do it. So you write model equals tf dot keras dot models dot sequential. Sequential is capitalized. And then you're going to do regular brackets, square brackets, and then in these brackets we're going to write 4 different layers. So the first layer is tf dot keras dot layers dot capital F for flatten. I will explain what all these mean, don't you worry. Input underscore shape equals open brackets 28 by 28, comma for the next layer at the end of this. I really hate that this covers it up because then you guys can't actually copy it down. tf dot keras dot layers dot dent. You can also copy and paste this. 128 underscore comma activation equals ILU tf. It's basically the same thing other than the part at the end. Keras dot layers dot dropout 0.2 comma tf. Stop covering it, please. Dot keras dot layers dot dense 10. Whew, that was quite a lot. And you're probably thinking to yourself, Fliss, what is this rubbish that you typed onto the screen? You've just typed in a bunch of garbage. I don't know what it means. I will explain it to you. So, each of these lines that we've written here are different layers of the model. The first one here, this is the input layer. So this takes a 28 by 28 pixel image and it sorts it into 784 features, and each feature is a single pixel. So, of those input images. So that's the first layer, your input layer. Next, you've got a hidden layer, and this is fully connected, and that means that every neuron in one layer is connected to the neuron in the next layer, and this has 128 neurons. So that's our first one. I'm also going to label these. So this is our input layer. This is our fully hidden layer. You don't really need to know what this means, to be honest, but if you ever are interested in the future, you might wanna know. The next layer is the dropout hidden layer, and this is to reduce the number of connections and thus the number of parameters that we need to look at. So this is the dropout hidden layer. And then finally, we have our output layer. And this will make the final prediction. So a lot of these artificial neural network models will be quite different, but what will always be the same is they'll always have an input layer, an output layer, and hidden layers in underneath. The amount of hidden layers might change, and they might have different layers depending on what it wants it to do, but that's generally the gist of it. I'm going to leave that up because I know that I have written quite a lot. And also just to show you what it looks like, I can write model.summary. You don't have to write this. And it will print out a summary of the model. Well, it should do anyway. There we go. Right. I don't want to take it off the screen, but if you remember what the diagram looked like of the artificial neural network and it had all of those layers, that's basically what we've just done right now. The only difference is this model is not trained, and basically 99% of the time it's going to get it wrong. well, it's gonna get it wrong most of the time. So we need to actually train it, and I'll show you how to do that now. But I'll give you guys a minute to type up everything. Okay, Comet has typed everything up. So now I can show you how to actually start to train it. So currently, this model is completely untrained. It doesn't have any kind of proper predictions. For example, if we type predictions equals model brackets train data let's do just the last one dot numpy, and we print out the predictions. Oh, what have I done? I spelled it wrong, that's why. Predictions. Yep, there we go. So it prints out a vector of numbers, and these are called logits. So logits are non-normalized predictions, and they represent how likely that input corresponds to each of the digits from 0 to 9. So there are, in this data set, there is digits from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And for the last value in that data set, these are all the predictions of how likely it is that it's a 0, or a 1, or a 2, or a 3, or a 4, or 5, 6, 7, 8, and 9. Aw, thank you guys for saying thank you. I realize that we are running out of time, so I'm going to hurry up. So my explanations are going to be a little bit speedy, but I'll try and get through this as much as I can. So that's what the predictions are. I can show you what they look like as proper probabilities. Basically, if you want to look at them as proper ones, you can do tf.nn softmax, and this function converts it into probabilities that you actually understand. Predictions dot numpy. So if I show you that, oh, thank you guys for liking the video. That's really sweet. That actually makes me really happy. But yeah, these are proper predictions from 0 to 1. So as you can see here, I'm pretty sure it thinks that the last value, yeah, that's the highest one there. So it thinks that the last value in the dataset is a 4. But let's check if it's actually a 4. So I'm going to write that. Current prediction. Last value in the dataset is a 4. And let's see if that's actually true. So we can do that by importing two libraries. So matplotlib.pyplot. Thank you guys for saying that in the chat. That's really sweet. That actually makes me really happy. And then import numpy as np. And then if I show you what the actual dataset looks like, I'm just going to quickly type this up. I'm show np.reshape train data. You don't have to do this, I'm just going to show you this. cmap equals. You make Mrs. Tank. Oh, Grace. And then plt.show. So current prediction is that the value that I'm going to print out should be a 4. But let's have a look. Yeah, that's not a 4. That's a 5. So you got to take into account that the network hasn't been trained yet, so this prediction is completely random. It doesn't actually know whether or not it's a 4. So let's actually start to train the model. One thing we need before we train the model is we need a loss. Basically, what the loss is a way in which the program can calculate the error of the classifier. So I'm just going to type this out, and I'll also type it in the chat so you don't have to type it out yourselves. But loss._fn equals tf dot keras dot losses dot sparse categorical. I'll explain what this means in a second. Critical cross entropy. Everyone who's watching that is thank you. I don't know what to say other than thank you. That's really, really sweet of you all. I just lost for words, but very, very happy. You've all genuinely made my day. So yeah, this will calculate the loss or the error of all of our connections. And let's see if I spelled it wrong. Yeah, I did. There we go. Keras. I might have to take maybe 5 more minutes of your times, guys. Hope you guys are okay with that. But I'd like to get this done. Oh, I spelled it wrong, didn't I? That's the problem when I'm always rushing. I'll just... There we go. Spelled it correctly. There we go. And that's how you calculate the loss of your function. If you're interested in what the loss is going to be, it's going to be around 2.3%. 2.3, because it's close to random, so it's going to be 1 out of 10 for each class. Yeah. So that's calculating loss. Finally, now that we have our loss, we can now compile the model. I will copy this, yes. Oh, that's good. I'll try and copy as much of the code into the chat as you can, so you don't have to type it all out. But basically, we're now going to use our loss function and choose an optimizer for training. So model.compile. We're going to use the Adam optimizer. If you're interested in what optimizers are, I recommend that you Google it. They're just a way of evaluating it based on weights and training time. But to be honest, you could write a PhD on this kind of stuff, so I don't think we really have the time to cover it. And I think I've spelled that all correctly. Yeah. So that's how you compile the model using an optimizer and a loss function. Next, as we've done every single session, you have to train the model based on the data, and we will do model.fit, and we will use our train data, our train labels, and we will use the number of epochs, so the number of cycles that we're going to go through. We'll make that 5. I'll also put that in the chat. There we go. And as you can see, we've got this cute little animation of it going through all the cycles and training it. I'm nearly done, by the way. So, once it's trained it, we can then test the model to make sure it works. So I'm going to add another wee little code bubble here. Yeah, it's quite cool, isn't it? You get to watch it like training through all the stuff, seeing how the accuracy works, seeing how the loss function's working. I mean, it's just a loading bar, but I think it's quite cool how that all works. While it's doing the training, I will show you how you could test or you could evaluate your model. Heads up, your model will be about 98% accurate on this particular data set, which is, for all intents and purposes, really, really accurate. It's really, really good. But if you want to know how you can test that, you can write probability model, if you can even spell it, probability model, and then you can wrap it in a trained model. So you can do tf.keras.sequential. Oh, it's finished training. Brilliant. And then in the curly regular brackets and square brackets, you can write model tf.keras.layers.soft max. and then you can use this to basically test your model. So I can print out a summary of the model, so probability model.summary. And that gives me a little summary of how it's working and all the different images I tested on it. I'm going to copy one bit of code onto the screen because I don't really have the time to type it all out myself. I'm just going to copy that in there. And that is how you can evaluate. Let's print the probabilities for the first 5 images. Thank you for everyone who's stayed behind for the last 5 minutes. I really do appreciate it. So, let's do for the 5th image instead. Let's just do 1 image. So, the 5th image in the dataset can be printed out like this. So, and I'll copy that into the chat as well. Basically, this will print out that 5th image. I think it's a number 1. It is a number 1. There we go. And what we can do is we can write a little bit of code to take out the probabilities like so. So what I've done here is I've put a vector of all the digits, and then it will take the probability model, try and predict what it is, and then it will write down what it thinks that number is. And hopefully it will say this is a 1. And instead this is a 1. So our model is about 98% accurate. There's lots of different ways that you can improve this model. You can change the number of layers, you can change the number of neurons, you can change the amount of epochs that you do, and you can see if the accuracy changes. But yeah, that is all of the code for making your own artificial neural network. I'll leave this up on the board as I go through the explanation, the conclusion. But yeah, that was the final session for these AI squads. I really hope you've enjoyed them as much as I've had. I have had an absolute blast teaching all these different AI and machine learning and deep learning algorithms. And yeah, thank you so much for showing up these past few weeks. It's been absolutely lovely seeing all your names pop up and seeing them all. But yeah, thank you so much, and I hope you've enjoyed them. Bye for now, guys.